We are so excited to dive into College Chemistry 101 with you all. As you're getting settled in and ready to watch this fabulous webinar, I'd love to direct you to the bottom of your Zoom window. Today we'll be using the chat bubble to communicate with each other. So go ahead and locate that chat icon on the bottom of your Zoom window. And if you click on that, a little chat box will pop up on the right side of your Zoom window. From there, you can send us questions. We only ask that when you send us questions, please make sure that your question is sent to everyone. That way we look like we're replying to real people and not talking to ourselves. So you can change that by clicking that blue button and just setting that to everyone. And to practice sending each other messages, go ahead and let me know in the chat box. Let's see. Do you have, well, yeah, all right. Do you have any pets? I'm looking at my 2 pet cats right now, and I am hoping that they don't bug me through the duration of this webinar. So I'd love to hear what animals are in your home or in your classroom. Jen says that they have a black lab named Casey. So sweet. What else do you all have? I would love to hear more. What about you, Melissa and Noose? Any pets in your an ant farm, Noose says.
It's not doing real well,
Oh,
but yeah,
Uh-oh.
it's right over there. It's like closest thing to creatures I want to have in my house, and it's
right.
even ants. It's like, ugh. But yeah, other things I don't do well with live things. There's not too many plants in here either, because you have to. I've heard you have to water them.
Yeah, that's what they say, but
Yeah, the ants. I was putting fruit in there, but I see stuff that looks black. That's probably not good. Have
let's
two
see.
dogs.
Eric
Oh,
says 2
yeah.
dogs.
Hello.
Wow.
And a
Oh, a
bird. I
German
like that.
Shepherd mix named Molly.
Hmm.
Cute.
Oh, Colleen would like the bird.
Yeah. 2
I like
Uh,
how
cats
it's phrased though, the dog and bunny we love, and a bird too. Like
and a bird in
the love
addition.
doesn't quite extend. Maybe
Poor
it's like
bird.
Amazing.
German
there's a
Shepherd
bird
mix
there
and
in the
oh,
Oh,
corner.
that's
cool.
great. Yeah,
The
yeah.
bird is available if asking, Michael Stark.
Love that. Love that.
That's amazing.
Oh my goodness.
Uh,
Oh, copper and nickel.
Two
That is
cats.
great. You are in the right
great.
scene.
No
Yeah.
silver or gold, but that's okay. Working up to it.
All right, my friends. Well, keep dropping your comments, your questions, etc. in the chat box. Remember, just set it to everyone, so everyone can share the knowledge and know what other people are wondering. It's a good way to build our educator community. To make the most of our time together today, I do want to hop into some quick housekeeping items. First and foremost, a recording of this webinar will be available on both our YouTube channel and our website. It usually takes us about 3 to 5 business days to get it edited and uploaded. So you may not see it until around this time next week, but as soon as it's ready, I'm going to email you a link to the recording. In that email, I'm also going to send you a link to our resources folder. In that resources folder, you can access today's presentation with clickable links, as well as a certificate of attendance. I'm going to drop a link to that resources folder as soon as I'm done talking, so you'll have access to all that in just a moment too. As I mentioned earlier, we want to answer your questions, so please drop those questions in the chat. We are here to help you. If we happen to not get to your question, please email us. You can reach one of these 2 fabulous presenters at chemistry@vernier.com. Last but not least, I'm going to go ahead and launch a Zoom poll. So keep an eye on your window and answer those questions when you see it, and enjoy today's webinar. Thank you for joining us.
Hi, everyone. I'm Melissa. And yep, there's that Zoom poll. Please answer it for us. And while we introduce ourselves, on Noose, I'm going to go ahead and let you introduce yourself.
Hi, my name is New System. I'm a chemistry specialist at Vernier. I taught high school chemistry and physics for 34 years in Maryland, and I've known David Vernier since 1984, so it's been over 40 years. I've been at the office for 9 years, and I'm loving it. The Northwest is wonderful, so yep.
Yep. And like I said, I'm Melissa. I'm the director of chemistry here at Vernier. And just like Dylan said, if you call the office or email chemistry@vernier.com, you're going to get myself or News. So we're probably the best people to talk to you about all the stuff that we're going to talk about today. Um, all right. So excellent. Good poll results there. And let's get started. Today here we are talking about the top Vernier sensors for teaching Gen Chem. And I want to take a step back and say, why should we use sensors in Gen Chem? And or in chemistry in general, or in the sciences in general, but in particular chemistry, um, it is we know that like doing sensor-based data collection or using technology in the classroom just gives you more precise measurements than say like pH paper or something like that. It's a great way for students to visualize abstract concepts that they're, hearing in lecture and reading about in textbooks. They don't really become real until they're actually touching the stuff and looking at it on a graph and understanding where that equation or where that number comes from and what it's telling them about chemistry and how that even relates to the real world. So it really helps engage all those areas of students. Green chemistry and sustainability, it's definitely going to reduce waste and hazardous chemical use if you're using a pH probe instead of synthetic chemical dyes, things like this. And then also it helps with like real-time feedback and hopefully also reducing chemical waste in that process because you can see the chemistry going on the graph and you're able to stop and change and start over. But we're also preparing them for their future careers as scientists, doctors, um, because that's what they're going to see in the workplace. And I know we've all heard that. I'm preaching to the choir here, but I wanted to start off with that because I think a lot of people still think of sensors in Gen Chem or technology in Gen Chem with these types of things, with these pH meters on a stand that have, one data point, and they give very accurate data. They give really reproducible, like, but it's a number on a screen. And so the student still has to write that number down in their notebook. And then they still have to go to Excel or Google Sheets or whatever program you're having them plotted in, and they have to plot it manually. And this is all great. I think this is a really valuable skill, and students do need to have this. But at some point in science classes, in particular, we need to be able to get this information a little quicker, have it live if possible, so that we can understand the graph that's coming in a little faster, relate it to that lab lecture, the equation, because we need to do something with that data in the lab, or we need to make sure that we got the right kind of data. So that's where I feel like Vernier's chemistry like solution is really, really helpful because it does all of that. It does it in live time. So you get a nice titration curve. You can do analysis directly in the software. You can have the calculated columns plotting at the same time. So for example, I'm showing a titration, and you can have the students do that all in lab. So they get all the answers there before they even leave. And so our software allows you to do that. Our probeware allows you to do that. And a lot of times people just think, oh, we sell pH probes, oh, we sell spectrometers. But no, our software is not just a meter screen. It really does allow you to take data and analyze it and incorporate it into your lab right then and there. And I also want to bring up, so not only is our software and hardware, designed for the chemistry classroom to help you get that information out of lab, but we also have a really, really robust curriculum lineup. So a lot of people don't know that we have this or think it's just sporadic or they just find things on Google. We do sell lab books. And we have quite an array of chemistry ones, actually. And what is a really nice advantage of our lab books is that when you purchase it, it's a one-time purchase, and it's between like $35 and $50. It's a site license. So everyone in your department gets access to that book, all the experiments in that book in their Word format. So you can edit them, photocopy them, distribute them as much as you want. And not only that, but you get free updates electronically through your Vernier account. So let's say you're a tried and true Logger Pro user using advanced chemistry and you have not updated, gone back to your electronic resources in a really long time, and now you're having to switch to graphical analysis, and all your instructions are for Logger Pro. Log on to your Vernier account and download the Advanced Chemistry with Vernier book from your account, and the graphical analysis instructions are there for that exact same experiment. You don't have to buy new chemicals. You don't have to get new sensors or anything. You just need the new instructions and they're already there. I do want to highlight a couple of things since we're talking very specifically about Gen Chem. I highly recommend the Advanced Chemistry with Vernier book for Gen Chem. If you do not have it or are not familiar with it, check that one out. It is a little bit more of a cookie cutter style lab book. It's nice to supplement it with the Chem Inquiry book because it is more of an inquiry style. And then Food Chem and Forensic Chem is just really good supplements as well to help bring some real world application in. And we are currently coming out with some green chemistry experiments, which are designed for the Gen Chem lab. Our intro chem book is kind of a more high school or like pre-Gen Chem. So if you have like an intro or course, that's a really good one for it. But I pull in a few labs from it today. And then we do have organic chemistry with Vernier, chromatography and electrochem. We have stuff for water quality, and there's a ton more books on our website. So I really feel like please check those out if you need help kind of getting started with your Vernier sensors and you don't want to reinvent the wheel. Those are a great place to start. So that's kind of what I'm going to go over today for these core Gen Chem labs. But seeing how the topics that you teach in Gen Chem, how you can incorporate sensors into those topics and what sensors those would be, what are the differences between some of our sensors for those topics. So I'm going to go through a lot of that. These are the topics that I'm going to cover that are talked about in Gen Chem. And then once again, if you've just joined us, please throw your questions into chat at any time. If there's something specific you really want to learn out of today's webinar, throw that in there as well. I want to make sure everyone's coming away with something and what they hoped this webinar would be about. All right, so acid-base chemistry and equilibrium is the first topic that I wanted to touch on, just because acid-base titration, we've already talked about it a little bit. And when you are doing an acid-base titration in your Gen Chem lab, you are hoping students are getting a graph that is helping them to identify equivalence points and determine strong versus weak acids and bases, getting Ka values. And so if that's the goal, in that acid-base titration lab, and you're doing that with a pH probe, you can also do it with a conductivity probe. But you're wanting them to get graphs like this. You're wanting them to get data like this. When you do tackle buffer systems and Le Chatelier's principle, really common lab done for acid-base chemistry and equilibrium, you want them to be able to get graphs like this and be able to tell that buffers are resistant to pH change, that how equilibrium shift, how colors shift to track changes in equilibrium, things like that. So we have several experiments for that in our advanced chemistry book. Also, we have green chemistry experiments for these. So we have some microscale titrations in some of our books, but in our new green chemistry books, we have acid and base titrations, and we're about to come out with one for Le Chatelier's principle using T. So keep an eye out for that. But pH probes. So we have quite a few different pH probes. The majority of people using pH probes to tackle, acid-base chemistry and equilibrium have this very standard pH sensor right here from us. And before I keep going with the sensors, I wanted to make a little caveat because I know we got a lot of questions in when you signed up for this webinar. You could put questions, and we got quite a few about Bluetooth and USB data collection. I'm exclusively going to be talking about our GoDirect line of sensors today. And those connect via Bluetooth or USB to Mac, Windows, Chromebook, iOS or Android device, LabQuest 2 or LabQuest 3. And really at this point, I don't recommend anything other than our GoDirect line of sensors. They are the newest technology. They have a lot of advantages over some of the cabled sensors. So particularly for chemistry, if you are purchasing new sensors, I would highly recommend really looking at the GoDirect line and embracing it, because buying old technology or kind of buying those sensors, there are reasons for it, but it's something I'm recommending with educators now quite a bit. And you'll hear a lot of the reasons why as I go through some of these different sensors. But our standard pH probe here is, it's a single junction pH. It's designed for aqueous solutions only. It's kind of our general purpose go-to. And it has it's kind of hard to see in this picture, but it has a round exposed bulb. And the difference then with the next pH probe is that it is a flat pH probe. And so you can see here the glass bulb that's there it's still a glass bulb, but it is flat right here. And this particular pH probe has a lot of advantages. Is a double junction. So you can use it with silver solutions. You can use it with sulfide solutions. You can use it with really strong or higher concentration acids, higher concentration bases. And you can also use it with semi-solids. So if you are doing some food chemistry or soil slurries for your environmental chemistry, it works really well for that. The other reason I've started recommending the flat pH probe over the standard pH is that while the standard pH has a lower upfront cost per sensor, that round exposed glass bulb can break, and it will break in the hands of students. And we can't repair that. It's once you break it, you have to replace it. And while the GoDirect line is nice that they have a BNC connection here, so you just have to replace the electrode, you still have to replace it. And so in the long run, you're going to be replacing those more often. And the flat one, the bulb is not exposed. It still can break, don't get me wrong. And it does happen, but certainly not as often as the exposed bulb. And it just has way more versatility. So I've tended to recommend this one more now than I used to. The glass pH, I certainly wouldn't recommend for Gen Chem unless you're really trying to stretch your budget and you need it for something else, because the entire electrode here is glass. So it's really designed for non-aqueous solutions, so like organic chemistry and stuff like that. So those are our pH probes, standard, flat, both very, very appropriate for Gen Chem. But then your titration, you still need more stuff, right? You can't just have the pH probe. We offer kind of apparatus devices for that as well. Our stir station, it's just a magnetic stir plate. It's not a hot plate. But it's nice if you, only need a few hot plates for your classroom and then you want like a magnetic stir plate for everyone. You don't already have them. It's pretty economically priced. Next is our drop counter. And so this is an actual sensor. It does like plug into the software because this is how you get that kind of titration coming in an automated way. You can do it in a manual way where you tell the software this is how much volume has gone into the beaker. So that is what is corresponding to the pH reading at this time. But if you, you've taught your students that, you feel comfortable that they need to really use titrations as a tool, the drop counter is really nice for that because you get through a lot of titrations much more quickly. And what it's doing is it holds the pH probe here, so you can see in the image here, and the reservoir is above the drop counter, and drops go through the drop counter, and then the software converts the number of drops that go through to a volume, so you get that kind of titration curve coming in. And then the last piece, the drop counter will come with a reagent reservoir, but over the years we heard, kind of some mixed reviews about the reagent reservoir, and depending on how much volume was in it, if it was really full or really low, the drop size varied, and so you could have some inaccurate readings with that. Now we offer this precision volume dispenser. So it replaces that reagent reservoir, goes above the drop counter. It doesn't matter if it's completely full or very low. It will give you the same size drop with every single drop. So I highly recommend it, especially like for your analytical, you're really, using titrations as a tool at that point. So those are all great for your titrations. The other thing that was in our experiments that we talked about for acid-base chemistry and equilibrium is spectroscopy. It's a really common one, especially for equilibrium studies, even using pH and spectroscopy together to do those equilibrium studies. And the GoDirect SpectroVis Plus, super common to be in the Gen Chem class. And I kind of think of pH and the SpectroVis Plus as like our the kind of the starters to the Vernier land, because people really know that we have those, and they're really good in Gen Chem. But if you're at a smaller school and you need to use your spectrometer also in maybe organic or analytical or instrumental, and you can't just get a fleet of SpectroVis Pluses, that they're great for Gen Chem, but by the time you get, into more advanced chemistry, you may want to actually go down into the UV, do some more quantitative fluorescence, or just have a little bit higher quality optics, or an all aluminum metal housing. Make sure that you look into those spectrometers as well. The SpectroVis Plus is visible only, so it goes from 380 to 950 nanometers. You get a full spectrum report out, but you can also sit at a single wavelength and do Beer's law studies and kinetic studies. So what you gain with the kind of more advanced spectrometers, particularly for equilibrium studies, is that extended wavelength range, more quantitative fluorescence, or just like a little bit better optics, particularly if you really need like, finer absorbance readings. All right, the next topic that is commonly taught in Gen Chem, you can't get out of Gen Chem without it, stoichiometry and solutions. And typically the data that you're wanting students to get out of this, and the concepts you're wanting them to come out of it with, are measuring ionic strength, comparing strong, weak, and non-electrolytes in real time, understanding the mole concept around that, how that impacts conductivity, certainly how solution color relates to concentration. Beer's law, I already mentioned, when we talked about spectrometers. There's a great green chem experiment that just came out using food safe dyes in sports drinks for concentration analysis instead of looking at that same copper sulfate, nickel sulfate, kind of the really harsh metal compounds that are really difficult to now even obtain, but to certainly get rid of. And then doing things like precipitation reactions, identifying what the compound is in the solution, doing all that kind of systematic looking through. So a conductivity probe is really useful for stoichiometry and solutions analysis. We do offer two different types of conductivity probes. We have our standard conductivity probe here. And the range for it is 0 to 20,000 microsiemens per centimeter, and it does auto range. So you no longer, there's not a switch on the box that tells you what range you will be measuring in. And it does, by default, have temperature compensation, the same 2% for sodium chloride, but that can be turned off. So you can actually look at conductivity readings as a function of temperature now. So if you want to explore that aspect of conductivity, and it even has a live temperature readout. So you can turn on temperature, you can turn on conductivity, and you can turn on non-temperature compensated conductivity, all within the same sensor. So it really has a lot of advantages that I'm a big fan of the conductivity probe. However, the standard one there is a graphite electrode. So you will get over time polarization effects. We've done a lot of things to mitigate that in how we've set up the circuitry inside. But that will happen. And then also the plastic that the conductivity electrode, the shaft is made out of, is ABS plastic. So if you're doing measurements in ethyl acetate or anything that's non-aqueous, strong acids and bases, you are going to erode that plastic over time, and you might have to replace it eventually. So that's why we came out with the platinum cell conductivity probe. So not only does it have all the same things that the standard one does, that 0 to 20,000, the auto ranging, and all the 3 sensor channels, but it has a platinum electrode in it, so it's better at handling those quick polarizations. And it has an epoxy body, so it has much better chemical compatibility. And you'll kind of see that as a theme in a lot of the chemistry sensors. It's like all of them have similar specifications, but the chemical compatibility gets better with the different versions, or just different, maybe not better, but different. And you can use the conductivity probes with a titration setup, just like we talked about with pH, with the drop counter and the precision volume dispenser. But you might just want to be reading conductivity of, household acids and bases, or looking at, different salts and how that affects concentration, things like this. A lot of people don't know, they're trying to use, C-clamps and all these different kinds of clamps to hold those electrodes. And then they end up clamping down on the top or on the BNC connector with the pH probes. And I really avoid that at all costs. It will give you weird data and it can damage the probe over time. We have these they're not very expensive, these electrode supports that will attach to the stir station or your magnetic stir plates. And they hold a probe very nicely in a beaker in a solution. So I really recommend looking into those if that's you're seeing damage pros in particular with the different kinds of clamps. All right, so our next topic is gas laws and kinetics. So from the gas laws and kinetics, in our experiment books, we have topics that I'm sure you are teaching when you go over these topics, Boyle's law, Charles' law, anything related to the ideal gas law, Pivnert. And you want students to come out of that with learning there's a direct relationship, there's an inverse relationship. You want them to use that information when they go on into kinetics and looking at kinetics over time, particularly if it's a gas producing reaction. There's a lot we have with like hydrogen peroxide or yeast and catalase, just determining rate laws from that. So this is a really good example of I've taken some, kinetics data. How do I make sure that I'm going to get the information out of it to solve what rate law am I following? What's the order of my reaction? And you can do all of that in software. And then finally, another big type of experiment that is done with gas laws and kinetics is Arrhenius equation experiments, so that temperature dependence of reaction rates. And this one, you're actually collecting a series of data sets and taking fits from those different data sets and then plotting them. So it's even more advantageous to have that have live data collection in your class instead of having the students collect, plot after plot and data set after data set to go to their lab report and realize that, oops, I messed up on my first trial and now all my data is wrong. And we have some great green chemistry applications around that using enzymes instead of metal catalysts. So look into that. So the gas pressure sensor is the go-to for doing anything with gas laws. And it's great for kinetics as well. We have a standard one that most people are familiar with. Its range is 0 to 400 kPa. And it comes with all these accessories. So when you first purchase it, it comes with a set of accessories that are really good for those out-of-the-box experience for Pivnert, Boyle's law, Charles' law, those types of things. But we also have a wide range gas pressure liquid compatible sensor. So this one has a wider range, higher accuracy, but it's also compatible with liquids. Not a lot of people know about this one. And again, I wouldn't necessarily recommend it for Gen Chem because it doesn't come as equipped out of the box to handle Boyle's law, for example. It's designed to be a little bit more robust to connect to your own systems, your own apparatus. So it has kind of little adapters and tubing and plumber's tape to make sure you get a really nice connection. You can set it up to do Boyle's law and all the other Pivnert, but it's really good at really when you need liquid compatibility or that higher range. On to thermochemistry. So looking at heats of reaction, calorimetry, enthalpy changes, any type of, looking at thermodynamic principles, temperature probe and a coffee cup calorimeter. In the software, you're looking at for actual like change over time, delta T, so just straight up statistics. It's very easy to do in our software. You're also looking at combustion reactions, energy that's released from burning tortilla chips and pretzels in the case of one of our food chemistry experiments. And we have several different types of temperature probes. So our standard temperature is really freezing and boiling of water. And it's great at that. I also highly recommend wide range temperature, particularly for organic or like one step away from Gen Chem. But it has better accuracy and the shaft diameter fits is made to go into your glassware for organic chemistry. And we also have a surface temperature probe, which is good if you're trying to measure temperature of surfaces. And then our thermocouple. This is great for Gen Chem, maybe like one or two for demos. I'm not sure you need one for like every student set, but it obviously is a thermocouple, so it has a huge range, liquid nitrogen, looking at flames, all that good stuff. And lastly, electrochemistry and redox reactions. This is becoming a huge topic with educators, given the how we're getting, change learning about energy storage and changing how we get energy. So really chemists need to learn this earlier and more often in the curriculum. At least I'm really hearing that from educators right now. So we're coming out with a lot of new experiments, particularly in our green chemistry experiments around galvanic cells and standard reduction potentials. So, just looking at how you would build a battery, different kinds of metals for building a battery, and then actually looking at different concentrations of that and getting from the graph, the Nernst equation, where the Nernst equation comes from. And redox titrations, if you're looking at oxidizing and reducing agents and how they interplay with each other. Looking at antioxidant activity in vitamin C in orange juice, for example. So to do those electrochemistry, the standard reduction potential ones, we actually have a really neat little kind of set, which includes the voltage probe and this little half cell plate. And so this is totally reusable. It has the salt bridge that is reusable, rechargeable in the center here. And you just fill the solutions of the well plate. And then we also have a little metals kit they're perfect little 2-inch cuts of metal of the different ones that you would look on a standard reduction potential table. And you have the students just play around with that, like have them decide their own solutions, their own metals, and figure out where that standard reduction potential table comes from. So this is a great series of items. So they're all, individual items, but that's a really good one for those first few experiments that you're doing in electrochem. Only have one ORP sensor, so don't need to get into that. If you want to do those redox titrations, that's the one to go to. Constant current system, I didn't specifically highlight, but if you want to do Avogadro's number or electroplating, that is a go-to for that. It eliminates having the need to buy a big, power source. All right, so you'll notice that I did not do any live demos today. I didn't think we'd have enough time getting through all of the different types of topics that Gen Chem goes over, but we have lots and lots of videos on our website. We've done webinars on titrations that go through and show the drop counter, the conductivity, the pH probe in action. We've done Le Chatelier's principle with spectroscopy and a pH probe was in that one. And then the Avogadro's number and the galvanic cell experiment that I talked about using that well plate and the metals kit was just done last fall. So please check those out. We also have short videos and tech tips and everything on our website, but also you can just go to our YouTube channel. And you can see them live and in action if you have any questions or if you have that equipment and you want to learn more about it. So again, in that kind of pre-lab sign up, when you were signing up to come to today's webinar, there was lots of people that asked about upper division courses. So this was specifically designed for Gen Chem, but I didn't want to ignore upper division folks or if you teach both. And so a lot of times, especially at the smaller schools, or if you just like, to have the same set of equipment for Gen Chem as you do for analytical or physical or biochem, organic, you can get any of the sensors we previously talked about and use them in an analytical chem. I would definitely go with like flat pH and drop counter and you'll be all set. But we have ones that aren't really, these types of instruments here don't really cover much that you do in Gen Chem. And I brought up the different types of spectrometers we have. So for biochemistry, analytical, physical chem, instrumental analysis, you probably need to go down into the UV. So our UV spectrometer goes down to 220. Our visible spectrophotometer, that one is just more accurate, has an all aluminum housing, so it has better temperature consistency. All of these have the option for a fiber optic to be purchased separately. And that'll allow you to do emissions. It'll allow you to do flame tests. So that is, for physical chemistry, certainly the gas discharge tubes. Inorganic chemistry, we have a cyclic voltammetry system if you do kind of more advanced electrochem. And then, of course, our mini GC, polarimeter, and melting point determination apparatus, our melt station. And those are all on our website. Our prices are on the website, so please check that out for any of the products that I discussed. Just want to refresh your memory. We have lots of curriculum. Software is all free. You can also use the LabQuest 3. It's really popular, actually, in Gen Chem labs to save benchtop space, and then you don't have to worry about IT. I also mentioned that our books are a site license. So if you have purchased them at any point, you have access to the latest version. So go to vernier.com, log into your account, and you will see them all there. If not, contact us. But that's how you'll get the latest and greatest versions, because we do update those pretty regularly. We have videos and webinars. I mentioned some specific for today's topic, but there's lots more on our website. And in particular, if you're just kind of getting started with graphical analysis or spectral analysis or instrumental analysis, we have some great videos for that. We do offer personalized training, so check that out on the website, request that. And if you still have questions, you're still uncertain with which probe should I use, what's great for my class, this is the type of setup I have, email us. We have chat on our website. You can also give us a call. And we are doing a giveaway today. So I'm going to let Dylan get that all ready to go. But Noose, was there any questions? You didn't interrupt me. So if there was any burning questions, I assume you tackled them in chat. But if there was something we wanted to discuss aloud.
We had a nice group today. I mean, definitely got some questions, and believe it or not, I was able to address them without having to interrupt you, which it doesn't always happen. But yeah, we had some good ones, and it was kind of fun to to interact with folks. So yeah, I'm glad people threw some questions at us, and like Melissa said, anytime, email, chat, call, we're there for you.
Yeah. And if you have any burning questions, please put them in chat now. We still got a couple minutes. And of course, the slide deck has lots of great resources and links, so please use that. And Dylan, you have you want to announce the giveaway winner?
Absolutely. Yes. So I entered everyone's names into a random name generator, and the winner of their choice of a GoDirect flat pH or an ebook of Advanced Chemistry with Vernier is Lori L. L as in lavender. We have two Loris online today, so it's Lori L. Congratulations. I'm going to email you to get your selection as well as any shipping information if needed. So keep an eye out for an email with from someone with an @Vernier email address. So congratulations, Lori.
Yeah, congratulations.
Yay.
Yay.
Yeah, there was a last minute question that I didn't know the answer to. It's this, what can you use for corrosion studies? And I wasn't really certain. I mean, probably voltage and current, maybe.
Yeah, you might want to email us with kind of more details about that specific application, like what angle you're looking at. But I mean, you can look at corrosion with yeah, the voltage probe, the current probe. You can look at it even with Yeah, those are probably the ones I'd recommend. Those sensors are about, I would say about $100 each. Again, all the prices are on our website. So if you just go to Vernier.com and search voltage probe, the price is right there. You don't have to request a quote. You don't have to call us up to just get a price. They're all on our website. But yeah, definitely email us if you have kind of more specific application notes on that particular question. And yeah, if there's nothing else, thank you all for joining us today. And if you have any further questions, chemistry@vernier.com, and make sure you log into that slide deck and get all those resources.
Thanks, everybody. Have a great rest of your day.
Thanks.